Bismillah. At 0.2 kilogram, particle P is constrained to move along the vertical plane. So you can see here this particle P is moving in a vertical plane, okay, in a circular slot. You can see here this is a circular slot, and radius r is given to us. It is 0.05 meter and is confined to the slot of arm OA, and at the same time this particle P is inside this slotted arm O2A, and which rotates about horizontal axis. So this is our horizontal axis, okay, but this whole system is in a vertical plane. So when there is a vertical plane, you have to use the G, okay. I will tell you later about it, okay, but the word is here vertical plane, so it is you must have to focus that G will work here, okay. I will come to this point later. With a constant angular rate omega 3 radian per second. So omega is given, and omega for what? For this slotted arm O2A is 3 radian per second. So here you can see this is angular velocity. Sometimes we write this omega is like omega like this, okay. And let me mention here that it is theta dot we also write, okay. For the instant when beta is 20 degree, the angle is 20 degree. Here you can see when angle is 20 degree, we have to find force exerted on the particle by the circular constraint, okay. So here we can see we have to find how much the normal force exerted by the circular constraint. See the word here, and which is circular constraint? This is circular constraint. So if the particle is here, for example inside the circular constraint, so the normal force may be working from this side or maybe from this side, okay. As per the problem, we have to find normal force by circular constraint, okay. Just focus your word. And the secondly, find the force R exerted on it by the slotted arm. So we have to find the value of R, but who is pushing this? I mean, who is producing this R force? Here you can see, as per the problem, by slotted arm. Slotted arm is O2A. This is slotted arm O2A, okay, and this will create a force on this body, okay. So this we have to find this R force. We solve this problem. Let's get some concept, okay. Suppose this is a particle, okay, and this is on this surface. So if I will ask you where is the normal force, so you can say it is perpendicular to the contact surface, okay. Now in the next case, I can say that this particle is between the two surfaces, okay, like here two surfaces, one surface here, another surface of this circular constraint. So you can say we can make two normal force, but we have to choose only one. It means it may be true that normal force may be working this side or maybe from this side. So in this type of situation, what we do, we actually choose only one normal force in any direction. So suppose I will say I am going to choose this normal force, and after my calculation, normal force is plus positive value then I will say my assumption was right. Okay, and if I get a negative value of normal force, then I will say no, my assumption was wrong, and in fact normal force is working in a reverse or opposite direction, and then I will say this is no. Okay, so this is one concept here. Now let's see another concept here. Before this is important to discuss here, I'm going to talk about this slotted arm, because they ask what will be the value of R. Okay, so to know where is this R is working, we should first imagine where is this particle P and how the force R is working. Suppose this is O to A, and I made this slot a rectangle, so it will be easy. And again I'm going to make this particle P as a like a cube, okay, to make it easier for to understand. Now I will ask you, when this OA is moving in this direction, what will be the, or where is the R force, in which direction? So it is easy to imagine that this force applied on this body will be perpendicular to the slotted arm. So we can see here that R is perpendicular to the OA. It is not in this direction, no, not here, not in this direction. So guys, we have to find the value of N and R. Okay, now question is that which type of this problem, how we can solve it. To know this, let's go back to the problem and let's see what are given. So we can see that mass of the particle is given 2 kilogram. Okay, and it is very clearly asked here that we have to find normal force and the force exerted by the slotted arm. So we can say here that we can apply equation of the motion very easily. Okay, and in this way we can calculate, we can make equilibrium of the forces, and we can find N and the R. So but the next challenge is here, which type of coordinate system should be used, X and Y, or R theta, or N and T. Okay, we have three options, so we are confused here what to do. It is a little bit confusion here. Which one should I go for, X and Y, R theta, and N and T coordinate? So let's go back to the problem and let's check out what information are given to us. So I will write some information to understand it. Okay, now let's see the values which is given in this problem. The mass is given, and if we see that R is given is 0.5 meter, and if we see here that theta value is given. Okay, and I will tell you how to calculate this theta. Theta will be equal to 2 beta. Okay, and the beta value is given as in this problem is 40. Okay, it will be 20 multiplied by 2. Okay, now question is how we got 2 beta. So I will tell you one concept here. Suppose we have a circle, okay, and in this circle, if you made a radius, or you can say diameter complete from this point to this, okay, and if you take any point on the circumference of this circle, and if you connect point A, and suppose this is A and B, to this point, so there will be certain angle. Suppose this angle is theta. Then if we connect this point to the center of the circle, the angle which it will make, it will double times of the theta. So if you can take this point anywhere on the circumference, and you will find the relationship between this angle and this angle will be always double times. That's why we applied this concept here in this problem here. Okay, if you see that we need to find theta at this point. Okay, why we need it, I will explain you in a few minutes. So this is the concept we have used here, that beta will be double for this theta. Okay, so now question is why we have calculated this theta here, not at this point O. So very nice. We see here in this problem that we have values for r and theta. Okay, so we are going to apply r and theta concept here. Now if we apply r and theta concept, so we need to know that particle is moving with respect to what? Where is the center? So we found that the center is at O dash. Okay, this is the real center. From with respect to this point, this particle P is moving. So we will apply r and theta concept from this O dash. Now I will find the another values from the problem. So we can see that omega is given as 3 radian per second. So as you know that theta dot is also omega. So this is 3 radian per second. And it is moving with a constant angular rate. Now we will move and we will try to find the value of theta dot. Okay, theta dot will be equal to 2 beta dot. Okay, but as given in this problem that beta dot is here. If you see, the point O is here and the omega value is given with respect to point O. So we need to find with respect to O dash. So in this case I will write theta dot is equal to 2 beta, because I wrote above here theta is equal to 2 beta, and the value for beta dot is given, and this is 3 radian per second. Okay, so this will be 6 radian per second. Now moving to the next point, we have to find, or we will try to find theta double dot. So guys, there is 2 ways. First I can say that I will take, or I will write 2 beta prime or beta double dot, and these are the constant quantities. As you see here that we have a 6 radian per second. So it means that acceleration is 0. Okay, and also if you go to the problem, you will find that this is rotating with a constant angular rate. So when the constant angular rate, it means that acceleration is 0. So from these information, we can say that we can apply r and theta coordinate system with confidence. So now let's move and make free body diagram for this point P using r and theta coordinate system. So guys, let's make free body diagram for this problem. So in fact I had to make a semicircle, so I could not, so I made a circle. Okay, so here you can see that this point P is on circumference. Okay, and I will connect this O with A or with the point P. Okay, and I will say, okay, suppose this is, I will say this is slot A, O to A. Now we have to make the forces which are working on this red particle P. So first of all, the basic fundamental, as you know very well, that you can make the force or weight force mg working in a downward direction. Okay, so this is easy to understand because we are solving in a vertical direction. Now the next question that we, as we mentioned, that we are using r and theta coordinate, and we already mentioned that O dash is our center of the motion of this particle. So let's make r axis. So as you know, I have to connect O with the particle P, and I will say, okay, here I made r axis. Okay, this is r, and r is always positive when it goes away from the center. Similarly, you will make the theta axis, and theta axis, as you know very well, that it is perpendicular to the r axis. So I will try to make a perpendicular. Okay, so here you can see that this is theta, and theta is always plus in the direction of the motion. So particle P is moving in a counterclockwise direction, so I made theta plus in this direction. Now let's talk about the other forces which are working on it. And as per the problem, there are two forces. One is N and another is R. So as I mentioned, that normal force working on both may be working from upward direction or maybe from the backward direction. So as you can see on the screen, I made either this one or this one. We have to choose only one. Okay, so in this case, what I am going to do, I will choose the normal force. Okay, and the normal force will be in the direction of R. Why it is in the direction of R? Because I have two options, either choose in this way, or opposite of it. So I will choose one side. Okay, now question is that why N is collinear with this R? So as per the rule I mentioned in the class many times, that if I have to find the normal or the R of this particle P on any curved path, so what I'm going to do, first of all, I will find where is the center of this curvature or this point, and I will find if this is the center, then I will say here is the center. I will connect it and I will say that normal force will work on this line. So similarly, we have used the same concept here, and we made normal force collinear with the R. Now the next question, where is R? And at the beginning of this video, I inform you about that R is perpendicular to the slotted arm. Okay, so where is the slotted arm? Slotted arm is O to A. So let's go and check out where is O and A. We see here O and A, so we can make perpendicular to this. This is R. Okay guys, so we are done with the all forces. Now we will try to solve these forces. Okay, here we can see that the beta is given to us, and this will be theta. So now let's solve equation of the motion. I will say Let's solve. F is equal to ma in r direction and in the theta direction. So first I will solve for the force in r direction. So I will write Fr is equal to mar, and you know that ar formula, we will expand this, and I can write is equal to mass multiplied by the r double dot minus r theta dot square. Okay, now let's balance the forces in r direction. Let's go back to the picture and see what are the forces here. Okay, so in the r direction, the force we see here, this is r. I will again mention this is r direction. Okay, this line, r axis. So we can see that there is a component of r and it is sine 20. How this sine 20, I will explain you in a minute. Plus the normal force, you can see it is plus, it's going outward direction, and the mg component, mg sine 40, okay, will be equal to the mar. Okay guys, let's see how we can calculate the angle. Let's see guys how we can calculate angle. As per this problem, the value for beta is given as 20, and n, the theta at this point is 40. Okay, so how much is this remaining? Is 140 degree, because this line is horizontal line will be 180. So this angle will be 20 degree, because this triangle will have 180 total degree. So if this angle is 20, the opposite side will be also 20, right? And you know that this is perpendicular to each other. So it means that this angle is going to be 20, and this angle between is 70, which is not relevant for you in calculation, but this 20 degree is relevant. Now let's move and we will calculate the forces in r direction. So I will equate all the forces working in r direction. So I'm going to write r sine 20 plus n minus mg sine 40 is equal to mar. Now ar is acceleration in radial direction. So guys, we will expand this ar formula here, and we can say this is our equation number 1. We will try to put the values, but mind here that r value is unknown still, and the n value is still unknown. Apart from it, if we see sine 20, we can calculate m and g is known, sine 40, and other side we have already expanded this formula for the acceleration. So I will put the value of mass as 0.2 and r double prime is 0. Why? If you see, there is no acceleration, no motion in the direction of r axis. So acceleration will be 0 in the direction of r axis. Okay, then we will put the value of r here. Okay, and theta dot is already known and we have already calculated, it is 6 square. So we can say this is our equation number 1 having two unknowns r and n. Now we will move to the solve the forces in theta direction. So if you see, go back to the picture again, free body diagram again, and check out please. So you will see that the forces which are working in theta direction r cos 20, and the mg component, that will be mg cosine 40, will be equal to 0. Why it is 0? Let's go back and check out. We wrote f theta is equal to ma theta. Now we see here that the acceleration, as per the problem, it was said that theta double prime is 0 because it's moving with a constant velocity. So it means this acceleration is going to be 0. So that's why we wrote that ma theta is 0. Now in this equation number 2, we can see that only unknown to us is r. The other thing is known to us, so we will find the value for r, and it is 1.599 Newton. And we can use this value of r in the equation number 1 to find the value for n. Now we got the value for n, which is negative. You can see here it is negative value. So what does it mean? It means that our assumption, which was n in this direction, is wrong. Actually n is working in this way. Okay, so this tells us about the direction of the normal force. Thank you very much. Don't forget to subscribe this channel. Have a nice time.